All right, hey Algebra 2 family. So I know a lot of us were struggling through that activating strategy for the August 10th stuff, or August 18th stuff. So I want to make sure that you're good that were true or false, and you got to explain your answer. So really quick, we're going to have this. If we multiply these two factors together, will that give us this? So easiest way to do this is either to distribute, or you can do the box method. So I'm going to show you two ways. So x times x is going to give me x squared, and x times 5 is going to give me 5x. And then I'm going to multiply that 3 over. 3 times x is going to give us 3x, and 3 times 5 is going to give us 15. Okay, so what we're going to do is we're going to combine our like terms, and hopefully your Algebra 1 teacher taught you that you can only combine like terms if they have the same term next to them. For instance, I'm only going to count players on a team if they're in the same jersey color. I'm not going to count the people who are on the opposing team because they're going to have a different jersey, right? So right here, these two both have x's, so we can combine like terms. So if we do that, we're going to get x squared plus 5 plus 3 plus 15. Now my question to you, is this the same thing as this? No, it is not. Okay? So the reason why it is false is because the b term is not correct. So there was some improper distributing, so something to keep in mind. Another way you can set this up is you can actually use the box method. And probably your Algebra 1 teacher taught you this way. What you're going to do is take these factors and set them up on the side. And just like how you would solve an area problem, you're going to multiply length times width. So x times x is going to give you x squared. X times 3 is going to give you 3x. X times 5 is going to give you 5x. And 5 times 3 is going to give you 15. Now we're going to add everything that's on the inside. And when we do that, we're actually going to get the exact same thing that we did up here. Okay? This is called distributing or distribution. Or maybe your teachers might have called it FOIL in the past. Okay? Down here, this is called the box method. Okay? Or the area model method. All right? All right, so on the next one, it said true or false, and then you're going to explain your answer. So this is set up like the box. Okay, so we're going to do our box method. So we're going to draw a box, and we're going to put our factors on the sides. So x plus 2 and x plus 4. And so what we're going to do is multiply the sides. So x times x is going to give us x squared. 4 times x is going to give us 4x. X times 2 is going to give us 2x. And 4 times 2 is going to give us 8. And so what I want you to notice, and I want to color coordinate these really quick. So give me 1 second. All right, so what I want you to notice is the fact that in the other box that they already gave us, this is the same thing as this. And this is the same thing as this. And this is the same thing as this. But look at what's really wrong. That 2x. Well, we've got x squared right here. Okay, so is this box true? No, it's false. And the reason why is because x times x does not equal 2x, it equals x squared. So just keep that in mind because that's a big mistake that a lot of people make. Okay? On the next one, you're trying to see true or false for the factors on this. Okay, so the first thing that I want to do is I want to create my big X. I'm going to identify my A, B, and C. So my A term is 1, my B term is -4, and my C term is -12. Okay, and so hopefully your teacher taught you that for the big X, you've got A times C. So 1 times -12. Well, if I take 1 times -12, that's going to give me -12. If I take my B term, I'm going to get -4. So I'm going to sit here and I'm thinking to myself, all right, what are factors of 12? I've got 1, 2, 3, 4, 6, and 12. So I need things that can multiply together to give me -12, but add together to give me negative 4. So I know that since this number up here in the top is negative, one of these numbers has to be negative as well. Okay? Well, can I add 1 and 12 and make negative 4? No. Can I add 3 and 4 and make negative 4? No. What about 2 and 6? Yeah, but I got to think, which one of those is going to be negative? Well, if I make 2 plus negative 6, that'll give me negative 4. Let's check the other way, though. Negative 2 plus positive 6, that will give me positive 4. So which one of these do I want? This first one. 2 comma negative 6. Okay? So now I'm going to take this and I'm going to put it into the box. A lovely, awesome box. Sorry. All right, so now I'm going to take that first term, and I'm going to put it in my first box, and the last term, and put it in the last box. And these two terms that I just found, I'm going to slap an X onto them and put them in this box right here and here. Notice how if I added everything up in this box, I'm going to get my original equation. So just keep that in mind. So now I'm going to actually factor. I'm going to take the GCF of the columns and rows. Okay, so I've got x squared and negative 6x. So if I pull out the GCF, I'm going to get x. If I pull out the greatest common factor from here, I'm going to get negative 2. So you want to think, what are factors of 2 and what are factors of 12? So which one do they both share? Negative 2. Okay, I'm sorry, positive 2. Okay, and we'll see why in just one second. X squared and 2x, well, we've got an x that they both share. And then negative 6x and negative 12. I can pull out a negative 6. One quick way to check this is if you multiply the sides of a box. So let's say you multiply negative 2 and 6, negative 6 and 2. That would give you this negative 12. What if you multiply negative 6 and x? That's going to give you this box. X and x, this box, x and 2, 2x. Okay, so the question was, is everything on the sides, this x plus 2 times x minus 6, is this the same thing as what they have written up here? Yeah, it's just written in a different order. It's the same thing based off of the commutative property. It's the same thing. If I say 2 times 4, it's the same thing as saying 4 times 2, right? So this one is true. On the next one, you're going to have to factor this one out. So we're going to repeat that process that we just did. So you're going to do the big X, and you're going to identify your A, B, and C. A is 2, B is 3, and C is 1. And remember that the quickest way to do this is to make sure that you know your standard form notation. It's got to be written out like this. If it's not, you've got to rearrange it. Okay? Your A term is the one that's attached to that x squared, and your B term is attached to that x. Okay? So now I'm going to take my A times C, so 2 times 1, and that's going to give me 2. And then I'm going to take my B term, which is 3, and I'm going to put it down here. Okay? So now I'm going to think, what are factors of 2? Well, all I have is 1 and 2, right? Now, can I add those together and make 3? Absolutely. So 1 and 2 are going to be our factors. And then we're going to draw our box. Look at those geometry skills. Okay? And our first term in the original problem is going to go in the first box. And our last term is going to go in the last box. And those two terms that we just found are going to go on the sides, here and here. So now we're going to take out the greatest common factor. So from this column, we're going to pull out an x because they both share an x. From this column, we're going to pull out a 1 because the only factors of 2 is 2 and 1, and the factors of 1 is 1. From this row, we're going to pull out 2x. From this row, we're going to pull out a 1. So our factors are going to be x plus 1 and 2x plus 1. Are either of these the same thing as what's written up here? No, this is false. Okay, and the reason why it's false is because the factor on this, or the term on this, when you take out the GCF of 1x and 1, you're going to pull out a 1, not a 2. Okay? All right, so this is on that second desmos link. This is the first problem. So what they want you to do is use the box method, and then they also want you to tell them the factors. So what you're going to do on this is you're going to do your a times c, which is going to give you negative 15. But first we need to make sure that we identify our a, b, and c. Sorry, I was jumping ahead. That's b, and that's c. Okay, and then our b term is going to be negative 2. And we need all the factors of 15. So 1, 3, 5, 15. All right, what two numbers can I add together to give me negative 2? So 1 and 15, I can't make that happen. What about 5 and 3? Well, yeah, but I've got to have one of them be negative. So what if I make that 5 negative? Would that work? Yeah. Okay, so we're going to plug this into our equation here. So we've got 3x here and negative 5x here. And we take our first term from the original problem and put it here. Last term and put it in the last box down here. And those two terms that we had here, we're going to slap an x onto them and put them inside the box. And then we're going to take the greatest common factor of the rows and columns. So from this column, we're going to pull out a 3x. From this column, we're going to pull out a negative 5. From this row, we're going to get an x. And then from this row, we're going to get a 1. So we're going to have 3x minus 5 and x plus 1. The quickest way to check this is to multiply back out. So if we take this and we multiply all of these factors back out, and we get the same thing as what we started with, we're good. If we don't, then we did something wrong in our big X or in our box. Okay? Hopefully this helped. Again, if you need to watch it again, that's fine. I know I talk pretty quickly, but want to make sure that we keep it under 15 minutes. Let me know if you have any questions. Y'all have a great day.